All right, boys, in this video, we're going to do a couple of examples, all right? And as I talked about at the end of the last video, it's going to say pause and try on a few of these. And what that means is pause the actual video you're watching, try the problem out on your own, then press play again to see if you got what I got. All right, so our second objective for this section is to recognize the expression obtained after simplifying is equivalent to the original. The way we're going to test that is by studying whether each pair of expressions are indeed equivalent. All right, so here I have 2k plus 5, and I have k plus k minus 5. All right, so we're going to figure out, are these two equal or not equal? All right, 2k plus 5 is as simplified as it can be, so that's why I just brought it straight down. K plus k in parentheses, I can go ahead and combine 2k, and then I'm going to subtract 5 from there. As we see, this is 2k plus 5, this is 2k minus 5, so it is indeed not equal. All right, now I want you to try this one here. All right, so take a look. It says 3y plus 4 and y plus 6 minus 2 plus y. And I want you to state whether it is equivalent or not equivalent. All right, so pause it right now, try it out, and then see if you get what I get. All right, boys, so 3y plus 4 again is as simplified as it can be. All right, on the right-hand side, with my y plus 6 minus 2 plus y, I have a few things that I can combine. And for this case example, I'm going to show you one way. For the example to come, I'm going to give you another way on how you can do this, okay? Right now, I'm going to put everything that's alike together. So y plus y goes together, and then my 6 and my minus 2 are going together on this side, okay? All right. So now I'm going to combine y plus y. That is equal to 3 times y, and that is plus 6 minus 2. 3 times y is 3y, plus 6 minus 2, 3y plus 4, because 6 minus 2 is equal to 4. So yes, this 3y plus 4 and 3y plus 4 are equal to each other. All right, now let's wrap this up with a couple more examples when it comes to combining like terms. You got to understand that when you combine like terms, you can also do that when they are subtracting as well. And here's an example of that. I want you to pause and try this, and then I'm going to let you know what your mindset should be when looking at a problem like this. Okay? Go ahead and pause right now. All right, so right now we have 8w plus 5w minus 7w minus w. They're all the same, so they're all alike. Now we're going to figure out how it is, we're going to put these together. All right, here's option 1. And this is my variable pot. All right, we're putting all of our like terms into one pot. All right, the pot just so happens to run off of addition. Okay, and we're going to just add these together. And here's why I want you to look at it this way, is because when this sign is in between two numbers or two variables or two numbers and variables, it is subtraction. Okay? Same here. This is 7w minus w. But if I were to cover up this 7w, now that turns into a negative w. You're going to eventually have to be looking at it both ways. Okay? So now, here's what I want you to do. I want you to throw all these numbers into a pot, and I want you to tell me what you're coming out with, okay? So 8w and negative 7w give you 1w, okay? 1w and negative w, 1 negative w gives you 0 w's, okay? So really all I'm left with is 5w, and that is my answer, okay? All right. Now, let's get into one more example that I want you to pause and try. Then we'll wrap this video up. Okay? All right. Pause and try this. It says n plus x minus n plus 3 minus x minus 2. Try it out. All right. So here's option 1. I want you to take a look at option 1. Option 1 is reordering this whole problem, putting the numbers that are in variables that are alike together, and then answering it from there. So in that case, I will put n minus n together, okay? Then I will put plus x minus x together. Then I will put plus 3 minus 2 together, okay? All right, and then from there, just combine like terms. N minus n gives me no n's, okay? Plus this x minus x gives me no x's, okay? And then I have plus 3 minus 2, and that gives me 1. All right, so therefore my answer is 1. All right, that's option 1. That's option 1. Option 2, I want you to make mini pots, okay? So it's kind of the same setup, but again, I want you understanding that they all run off addition, okay? And I have an n and a negative n, I have an x and a negative x, and I have a 3 and a negative 2, okay? And if I were to put these together, combine them, what am I coming out with? In this case, 0, in this case, 0, and in this case, 1, and then that is my answer. So either way you look at it, you know, like I said, I want you to identify that right here it says x minus 2, but if I cover up that x, that is a negative 2. You got to understand both. And once we get into working with more integers and expressions, it'll all make sense. All right, last example, boys, and then you're on your own. All right, you're going to see a problem like this. It says find the perimeter of the rectangle in terms of x. All right, so geometry's coming up in the future. You probably got a couple more months till we get there. A rectangle has 2 pairs of parallel and 2 pairs of equal sides, okay? And perimeter means the outside. So in a sense, that means that this is also 2 plus x, and this is also x. Got me? All right, so now what I'm basically going to be doing is adding them all together. So I have x plus 2 plus x plus x plus 2 plus x. All right, or that's the same thing as 2 times x plus 2 times 2 plus x. All right, this brings me to my next piece that's going to help us lead into 7.4, and that is what's called to distribute. All right, so here's what I'm faced with in the problem above. All right, I have 2 times 2 plus x. So I am going to distribute the 2 on the outside into everything on the inside. And my operation along with that is multiplication. So I'm going to multiply 2 times 2 and get 4. And then I'm going to add, because this is my operation on the inside. If it were subtraction, it would be subtract. I'm going to add 2 times x to that, which is 2x. Okay? So now when I go back to the above problem, I have 2 times x, which is 2x. Then I have plus what I just figured out, 2 times 2, and then 2 times x. Okay? So I end up having 4 plus 2x. And now I'm going to combine like terms. My 2x and my 2x go together, and my 4 stands alone. 2x plus 2x gives me 4x, and I bring my 4 down. And then I cannot combine any further, so this is the perimeter of my rectangle in terms of x. All right, boys, these examples should help you with everything you're asked to do today. You're going to go throughout the book and work on the guided practice problems. And then at the back of the chapter, there are some examples that I want you to try as well. All right, if you have any questions, please email me. But like I said, I'm sure you all will be fine.